Hi guys, let's solve decrease 2 radians. So I am having problem. Calculate the angle of 1 degree, 1 minute or 1 arc minute and 1 second or 1 arc second. So 1 second of arc or arc second in radians. So we need to convert these degrees, minutes and seconds in radians. So we know the early knowledge, that is that so a circle which is having 360 degrees. So if we can take this is a circle of total, so this circle having 360 degrees and this 360 degrees will equal to 2 pi radians. So that knowledge we already having. A circle which is having 360 degrees and that 360 degrees is divided into 2 pi radians. So this is the basic knowledge, we know it. Otherwise if you can take your protractor, this protractor is having 180 degree and if you can take one more protractor right down, so it is having 360 degrees. So 360 degrees equal to 2 pi radians. So by taking this is the prelim knowledge, so I can take that, we are going to calculate that. So 360 degree equal to 2 pi radians and I can calculate what is the 1 degree in terms of radians. So for that I can write that 360 times 1 degree. So 360 times 1 degree which equal to 2 pi radians. So I can write 1 degree equal to 2 pi upon 360 radians. So this radians I can write on the numerator radians and we can cut 2 in 360 equal to 180 times which equal to pi by upon 180 radians. And you can substitute the pi value which equal to 22 upon 7 times 180 radians. Suppose if you can use my calculator at here, so pi value equal to 22 upon 7, so that divided by 180 which gives me 0.01746. So I can write that at here. So 1 degree equal to 0.01746 and so on. So I will round figure this value and I will write in terms of scientific notation. So that gives to me 1.745 times 10 power minus 2 radians. So this I round figured how it is 1.45, otherwise you can take that as 6. So if we can round figure the rest of the all the values, so that becomes as a 1.745 times 10 power minus 2. So this is the scientific notation. Therefore I can write my answer 1 degree equal to 1.745 times 10 power minus 2 radians in terms of radians. Now to calculate 1 minute. So we know that from the previous concept 1 degree equal to 60 minutes. So if you can remember this figure, degrees into minutes, 1 degree equal to 60 arc minutes. So from this figure I can write that 1 degree, so 1 degree equal to 60 minutes. Now we already converted 1 degree in terms of radians, that equal to 1.745 times 10 power minus 2 radians. So this is the value of 1 degree equal to 60 seconds, sorry 60 minutes, which is also equal to in terms of radians. Now I need to figure it out what is the value of 1 minute. So the 60 minutes I can write that 60 times 1 minute, which equal to 1.74 times 10 power minus 2 radians. So 1 minute equal to 1.74 times 10 power minus 2 upon 60. Now if you can do the further simplification, so that is 1.74 times, so I can take the 10 on numerator, so that is I want to write the 6 times 10, 10 power minus 2. So this is supposed to 10 power minus 2. If you can take 10 to the numerator, it becomes 1.745 times 10 power minus 3 upon 6. So if you can divide that in the calculator, I can get that. So 1.745 divided by 6, which gives me 0.2908. So I can take single value 0.290. So therefore 1 minute equal to 0.290 times 10 power minus 3 radians. So you can convert this in terms of scientific notation, take it out the point. So I would like to write that, so 2.90 times 10 power minus 4 radians. So this is the value of 1 minute in terms of 2.90 times 10 power minus 4 radians. So I can mention that at here. So therefore 1 minute equal to 2.90 times 10 power minus 4 radians. So that is the second one. So let's calculate the third one, 1 second. So from figure I can take again 1 second. So this is the seconds to minutes. So 1 second equal to 60 minutes. So if you can take from here, so I can write at here 1 second equal to 1 second, sorry, 1 minute equal to 60 seconds. So 1 minute equal to 60 seconds equal to, we know that 1 minute in terms of radians, I can take that as 2.90 times 10 power minus 4 radians. So this is 1 minute in terms of seconds and radians. Now I need to convert 60 seconds as 60 times 1 second, which equal to 2.90 times 10 power minus 4 radians. So if you can divide 1 second equal to 2.90 times 10 power minus 4 upon 60 radians. If you can do that calculation, we can end up that 4.85 times 10 power minus 6 radians. So therefore 1 second equal to 4.85 times 10 power minus 6 radians. So this is the second 1 second value in terms of radians. So if you can mention my final answer right here. So 1 second equal to 4.85 times 10 power minus 6 radians. So these are the corresponding values of the degrees in terms of the radians. and minute is the lower unit of degree. So 1 minute equal to 2.90 times 10 power minus 4 radians. Similarly, 1 second equal to 4.85 times 10 power minus 6 radians. Next problem. The moon is observed from two diametrically opposite points A and B on Earth. The angle theta subtended at the moon by the two directions of observation is 1 degree 54 minute. Given the diameter of the Earth to be about 1.276 times 10 power 7 meter. Calculate the distance of the moon from the Earth. So let me draw a diagram first to make better understanding. Suppose if this is moon, let me highlight that. So this is moon, and if I draw Earth, so this is Earth. Now this is Earth. Now for Earth, it's having diameter, and they are given the diameter value. So the diameter value equal to 1.276 times 10 power 7 meters. Now from points A and B on the diameter, they are observing the moon, the position of the moon. So if we can take that an angle at here, from this diameter they are observing the moon at one point, and from point B they are observing the moon at another point. Two different locations of the moon, and this angle subtended. So the parasitic angle at here, so that angle is mentioned that as 1 degree 54 minute. Now what we need to find? We need to find the distance. Suppose if I take this as O, we need to find the distance OA. OA equal to how much? Now the angle subtended at here. Now if we can take, this is an angle at here, so this is the angle, so the parasitic angle which is given. So from the given values we need to find that. Yeah, it's very easy. We can find it out that by using theta equal to arc length by radius, arc length upon radius. So here the radius equal to, so theta here, arc length equal to AB, and the radius equal to OA. So I can find it out, OA equal to AB upon theta. AB is given in terms of meter, and we need to find the theta in terms of radians. So if I take given, so given that theta equal to 1 degree 54 minute. Now we need to convert this degrees into radians. Now 1 degree 54 minutes equal to, first I will convert the degrees in terms of minutes. 1 degree equal to 60 minutes plus 54 seconds, sorry, minutes already is there. so which is equal to 114 minutes. So 1 degree 54 minutes equal to 114 minutes. Now we can convert this 114 minutes. So therefore 114 minutes equal to, we will convert in terms of seconds, 114 times 1 minute, which also equal to 114 times 60 seconds. Okay, so 114 minutes, and we know that 114 times 60 times, I can write 1 minute. So this 1 minute you can convert in terms of 114 times, sorry, here it is supposed to be seconds, 60 seconds. 60 times 1 second. 1 second I can write in terms of radians. It is 4.85 times 10 power minus 6 radians. Why? Because since I can write that here, since 1 second equal to 4.85 times 10 power minus 6 radians. So now we got that the total minutes in terms of radians. So if we can write that radians value, so 114 minute, which also equal to 1 degree 54 minute, which also equal to 3.32 times 10 power minus 2 radians. Now we got that value in terms of radians. So this is the degrees value is given, so this is the conversion of the radians. Now we will substitute that in the given formula. So we need to find the radius. So theta equal to arc length. So here the arc length is given upon by AB. Upon the radius I have taken AO. Now AO means nothing but radius equal to AB upon theta, theta in radians. So that you can observe from the figure which I draw. So AB is the diameter of the earth. So they are given that. So why it is the arc length which I mentioned? So the triangle which I mentioned. So this is the triangle which we are going to mention. So from these triangles we are having theta and we are having the side AB. Now we can measure the side AO by the formula. So AO is radius. So the AO at here, the distance AO is nothing but the distance from earth to moon. Therefore the distance from earth to moon, that is AO, which equal to AB. You can substitute the AB value. So the AB value which is given that 1.276 times 10 power 7 meters upon, and the theta value here I got 3.32 times 10 power minus 2 radians. So if you can do this calculation simplification, do it by yourself, so that I can reach a value that 3.84 times 10 power 8 meters. Therefore the distance between earth to moon is 3.84 times 10 power 8 meters. So this is the final result what we need to calculate. So the given value, the theta, we converted into seconds, and that after we converted into radians. So this conversion we should learn properly. So I am giving similar model as an example. You try to do by yourself. The sun angular diameter is measured to be 1920 minutes, and the distance d of the sun from the earth is 1.96 times 10 power 11 meter. Now what is the diameter of the sun? Now in this case just we need to do opposite. Now if we can take that as sun, so let me draw one more time. So this is sun. Now we need to measure the sun diameter. Suppose if I draw a line at here, and from the earth, so we are observing the sun diameter at two angles. So these are the two angles we are measuring the diameter of the sun, and this angle is measured in terms of the minutes, 1920 minute, and the distance from the earth to sun, so this is the distance they are already given, that 1.496 times 10 power 11 meter. Now we need to find that AB, if the AB is diameter of the sun. You use the same formula, theta equal to arc length by radius, arc length upon radius. So here I need to find the arc length AB, AB upon, if I can take radius as OA. Therefore arc length AB equal to theta times OA. Now we need to convert the theta. AB equal to, the theta is given that 1920 minutes times OA. OA value is given that 1.496 times 10 power 11 meters. Now first we convert this 1920 minutes in terms of seconds. So if we can do that at here, so 1920 minutes, which is also equal to 1920 times 1 minute. So 1920 times 1 minute I would like to write as 60 seconds. Now 1920 times 60 times 1 second. Now if you can write the value of 1 second, 1920 times 60 times 1 second, the 1 second value if you can take from the previous, 1 second equal to 4.85 times 10 power 6. 4.85 times 10 power minus 6 radians. Now we got everything in terms of radians. Now this value if you can substitute at here, you can get that AB equal to 1920 times 60 times 4.85 times 10 power minus 6 times 1.496 times 10 power 11 meters. So if we can do that calculations, we can end up the final value in terms of AB. So AB value equal to 1.39 times 10 power 9 meters. So which is the diameter of the sun.